In this lesson, we will be looking at quadratic functions, specifically how to graph quadratics. And you should be familiar with a few topics from Math 10, which are really going to help in this lesson. And that is how to graph linear equations and how to produce those graphs, which we'll go over an example, and also some basic algebra knowledge. If you know that your algebra is a bit weak because it's been a while since you've taken Math 10, I really encourage you to go to this link here, which is going to open a review sheet with answers for algebra. And if as I go you need some more practice on how to determine coordinates of points, then check out this applet here, and it's going to be of a lot of help for reviewing basic graphing. And on that note, I'm just going to make sure that we all have some knowledge of graphing. So when we look at a graph, we need to remember that this is the x-axis going side to side, and the y-axis here is going up and down. And also, this here is going to be numbered, so we're going to number it 1, 2, 3, 4. So positive numbers are going to the right along the x-axis, and negative numbers are going to the left. Similarly, on the y-axis, we have positive numbers going up, and we have negative numbers going down. And any time that we put a point on this graph, it's going to have two coordinates, one x-coordinate and one y-coordinate. So for example, if I put my point right here, its x-coordinate is 3, and its y-coordinate is 2. And this is the way that we always write points. So we put their x-coordinate first and the y-coordinate next. I'm going to do a couple more examples here. So let's say there's one here, and this one's going to be right on the y-axis. And when that happens, when it's right on the y-axis, the x-coordinate is 0. Because if you look straight up here, it's just directly in between the -1 and the 1. So its x-coordinate is 0, and the y-coordinate is right on -3. And one more example over here. This x-coordinate is -2, and because it's right on the line, the y-coordinate is 0. Okay, so again, if this is something that you really need some more help with, take a look at the applet and get some good practice in on graphing points. But we're going to move on here in the lesson to just a quick review of a linear function. So this would be something like f of x equals 3x minus 2. And this is what you would have seen in Math 10. And so we know that this is a linear function because this x right here does not have an exponent. So it's not x squared or x cubed, it's just x. And also another reminder that f of x you might also see as y. So we could also write this as y equals 3x minus 2. And then when we want to graph this line to see where it goes on the coordinates, we're going to take a few points. And the points that you probably would have looked at when you're doing a line is the y-intercept, the x-intercept, and probably one other point. Okay, so finding the y-intercept is where it crosses the y-axis. And that's going to be all along this y-axis, x is equal to 0. So to determine the y-intercept, we can actually set x equal to 0. So y is going to be equal to 3, and I'm going to replace x with 0 minus 2. So now 3 times 0 is 0, minus 2 is negative 2. To find the x-intercept, I'm going to put 0 for y, and then solve. So I'm going to move the 2 onto the other side. So I have 2 equals 3x. Divide each side by 3, which gives me x equals 2/3. And if at this point you're having trouble with the algebra, remembering how to move the numbers around to solve for x, take a look at that review sheet at the top of this lesson. And then finally, to find one other point, I'm just going to choose an easy one to find. So we're going to say when x is 1. So when x equals 1, y equals 3 times 1 minus 2, which is 3 minus 2, which is 1. So now I can go ahead and put these on my graph here. So the first one is the y-intercept. So it crosses the y-axis at negative 2. So if I draw here, negative 1, negative 2, okay, and so crossing the y-axis at negative 2. So we're going to have a point right there. And it crosses the x-axis at 2/3. So that's going to be most of the way to 1. And then another point is at 1, 1. It's right about there. And then I can draw my straight line, like so. And so that's it. And then a lot of the rest of your grade 10 for linear equations was spent just finding the slope of that line. And so now we're going to move on to the actual notes here for the foundations of Math 11. So the new things that we're adding in foundations of Math 11 from what we just reviewed in Math 10 is quadratic functions. So we're going to talk about what quadratic functions are, as well as being able to graph them. So the definition of a quadratic function is just a polynomial that has a degree of 2. And so I really encourage you to print out these notes and to fill in the blanks as we go, as it's just going to help you pay more attention and is really going to help you to do a better job of the assignment later. And so degree is the highest exponent in the polynomial. Okay, so when we were talking about linear functions, our example there was just something like that. And so the degree here is just 1. And if we were to change the polynomial to be 3x squared plus 2, which is what we're going to see in grade 11 math, the degree is 2. And here's a couple more definitions that you're going to see. Polynomial is just a math expression with numbers and letters but it's not divided by a number. A parabola is just a U-shaped graph and is produced by a quadratic function. So we're going to go ahead and move on to the first example here, which is the most basic of quadratic functions, and that's y equals x squared. Now when we're asked to graph quadratic functions, the first thing we do is make a table of values. And in this table of values, one column is going to be for x and one for y. So these are going to represent our coordinates of the points. And I always start out with x being -2, -1, 0, 1, and 2. And to find the corresponding y coordinate, all we're doing is looking at our equation. So y is equal to x squared. So when x is -2, y is equal to -2 squared. And that's just 4. When x is -1, y is equal to -1 squared, because -1 times -1, +1. And similarly, as we go down the table, we get our coordinates for y. Okay, so now we have 5 different coordinates that we can plot on the graph. So our coordinates are -2, 4, -1, 1, 0, 0, 1, 1, and 2, 2. Okay, so I'm going to plot those on the graph here. So we've got -1, -2. So we've got -2 and 4. 1, 2, 3, 4. And then we've got -1, 1. We've got 0, 0. We've got 1, 1, and 2, 4. Okay, and so now we make our parabola shape. And we say that this parabola opens up and that this point here is called the vertex. It's right in the middle of the U, and it is also a minimum because that's the very lowest point on the graph. So here's another example with a bit more of a sophisticated equation. And so again, I'm going to put my x and my y. And my test points, -2, -1, 0, 1, and 2. And then I need to go through doing the math to figure out what the y coordinates are. So I'm going to plug in -2 for x in the equation. We're going to get -2 squared plus 2, -1 squared plus 2, 0 squared plus 2, and so on. Okay, and so this is the same thing as just -2 times -2 is 4. So we've got -4 plus 2, which is equal to -2. Our next y coordinate is going to be -1 plus 2, which is equal to +1. This one's just going to be equal to 2. And this one's going to be, again, -1 plus 2. And down here, -4 plus 2. And -4 plus 2 gives us -2. So again, we're going to graph our points. So we've got a -2, comma, -2. We've got a -1, comma 1. A 0, comma 2. and a 1, comma 1, a 2, and negative 2. Okay, so when we draw our parabola shape in, we end up with this. And now this one opens down and has a maximum. Okay, and so now we are going to carry on to our last example here, which is y equals 1/4 x squared minus 3. So again, we are going to label our columns as x and y, and we're going to use the same test points, -2, -1, 0, 1, and 2. And then we're going to put our x points into our equation and solve for y. So in the first example, we have 1/4 -2 squared minus 3. We have 1/4 -1 squared minus 3. 1/4 of 0 squared minus 3. 1/4 1 squared minus 3. And 1/4 2 squared minus 3. And when you multiply these out and add things up, you should get -2, -2 and 3/4, -3, -2 and 3/4, and -2. So now we're going to take these points and we're going to plot them. Our first point is -2. And I'm going to actually expand this out this time. So I'm going to label -1, -2, -3, 1, 2, and 3, -1, -2, and -3. So I'm skipping one grid line each time just so that I can expand this drawing to make it a bit more clear. And that's fine, but just make sure that each time you go up by the same amount. So I'm skipping one grid line each time. I'm not changing it, otherwise you're going to skew the graph. So we're going to put our first point in at -2, comma, -2. Our next one in at -1, comma, -2 and 3/4. At 0, -3. At 1, and -2 and 3/4. And at 2, comma, -2. And so now we're going to draw this out into our parabola shape. And that's the general shape. Again, it opens up. But notice from our graph here, just like all the other parabolas, we've got two places where the parabola crosses the x-intercept, or crosses the x-axis, sorry. And so we've got two x-intercepts. And from this graph, we can't really be sure. We could guess what those numbers are, but we're going to spend quite a bit of a unit looking at how to find those x-intercepts. And so in the next lesson, we are going to look at some of the properties of the graphs, such as the intercepts and the vertex down here, as well as axis of symmetry and a couple other variables. So if you are quite sure that you're ready to move on, just take a quick time here to look at the checkpoint. So make sure that you can do this question on your own, and the answer to this checkpoint will be posted in the course Moodle page, so you can check your work, and if you've got it correct, then you are good to move on to the next lesson.